Hi everyone, in this video we're going to go over the rectangular components of a vector. And before jumping into any definition, I just want to go over a process and extract as many pieces of information that I can. And I think in that process we'll discover what really the rectangular components of a vector are. So let's begin by drawing some general vector, and let's call it vector A. And now let's drop two perpendiculars, respectively on the x and y axes. So we can now see that we can draw the components of vector A, and let's draw the horizontal component. So I'll draw that a bit neater. And we'll call that vector A sub x, and the vertical component, which is A sub y. Now we can write vector A as the sum of its components, which is A sub x plus A sub y. Now, if I were to consider the angle that forms between vector A and its horizontal component, so let's call that angle theta, and we see that angle theta, or the sine of angle theta, is equal to the opposite side over the hypotenuse. And in this case, that's A sub y, or to be more precise, the magnitude of A sub y over the hypotenuse, or the magnitude of the hypotenuse, which is the magnitude of A sub, or just A, right? So that's the magnitude of A. Now let's consider the cosine of this angle theta. So the cosine of this angle theta is equal to the magnitude of A sub x over the magnitude of A. Now if we were to write these ratios in a slightly different form, we see that we can actually now have a definitive way to determine the magnitude of the two components. And we can write this as the magnitude of, or let's use red, the magnitude of A sub y is equal to the magnitude of A times sine theta. And let me just write that a bit neater, so that's sine theta. And the magnitude of A sub x is equal to the magnitude of A times cosine of theta. That's cos, let's write cos theta. And this is a really important relationship, and we can actually further find a relationship between this angle theta and the two components. So if we divide the two sides, so we have A sub y over A sub x, or the magnitudes actually, what we get is the magnitude of A, right? So we get this sine theta, and then you can probably see where I'm going with this, but I'll just write that out. So, or cos theta, and we cancel this out, so we get sine theta over cos theta, which is equal to tan theta. So we now have a relationship between the angle theta and the two components of this vector, and we can write that out I guess more explicitly in that the angle theta, and let me write that out in red actually, so we've got the angle theta is equal to the arctan, or tan inverse, of the ratios of the vertical component, or the magnitude of the vertical component, over the magnitude of the horizontal component, just like that. And with this, we can now fully describe the rectangular components of vector A, and that's it. That's really all you got to know, and I hope you enjoyed this video, and let me know how I did. Thank you.